So I'd like to talk a little bit about finding the domain of the functions. And just a little bit of review. The domain is the set of all possible inputs, which are your x values, remember. The range is the set of all outputs. Usually, the one that we spend a little bit more time on is the domain. It's the one that's a little easier to find. The range is pretty tough to find without actually looking at the graph. So I'll go over a few things that you can look at to find the domain. So here are some steps you can use to find the domain. They will not work with everything, especially once we get to logarithms and trig functions, but they'll work with everything we're doing right now. So first of all, start by assuming the domain is the set of all real numbers. By the way, just a little notation thing. We write the set of all real numbers like this. That just means the set of all real values, real numbers. It's an R, but it has like an extra little thing on the side of it. So then the second thing is, if the equation has a denominator, you're going to exclude any number that gives a zero denominator. So basically for that, you can just set your denominator not equal to 0, and then you're going to solve from there. The next thing is if the equation has a radical of even index. So if you have like just a square root, that's an even index. It's an index of 2. If you have a cube root, that's an odd index, so that one would probably be all real numbers. So if you have a radical of even index, you're going to exclude anything that can cause the radical to be negative. If you have a negative, I just realized that my spelling was auto-corrected. Sorry about that. This should be the radicand. But for some reason, that word is not in the dictionary on this program that I'm using. So if anything that can cause the radicand to be negative, which is the expression inside the radical, that actually will give you an imaginary number, which obviously is not a real number. So when that happens, you are going to set the radicand to be greater than or equal to 0, unless it's in the denominator. In that case, you're going to set the radicand just to be greater than 0, because we already know that we can't have a denominator equal to 0. Okay, so let's go ahead and do some examples. Actually, before we do an example, I just want to make sure that you know the notation that's used in your book. With domain, you will see all sorts of different notations. You'll see interval notation. You'll see just greater than, less than, not equal to. It's different pretty much for every class. I'll show you the one that you will probably see the most. You're usually going to see something like this. So if you see something like that, this means the set of all real numbers x, that's that first part. The line means such that, and then we just have x is not equal to 2, x is not equal to negative 2. So this is actually read as the set of all real numbers x such that x is not equal to 2 and x is not equal to negative 2. So that's the notation that you'll see frequently. Lots of different ways to write these though. So here's 4 examples. You're welcome to fast forward or just to pause, then fast forward to the answers to check. I am going to go over all of them. So for number 1, the domain of this is actually all real numbers. The reason it's all real numbers, we know that there's no fraction, there's no radical, so there's nothing objectionable in this. So it's going to be all reals. By the way, you'll sometimes see me write it as just all reals, in case you're wondering if I do that. Not perfect, but the R with the set of all real numbers is probably the best way to write it. It's the shortest. For number 2, we have a denominator, so what we're going to do is we're going to say that that denominator is not equal to 0. If you solve that out, you get that t is not equal to 3, and t is not equal to negative 3. So I'm going to write my, my notation as t, the set of all numbers t, such that t is not equal to plus or minus 3. And that's my domain for that one. For number 4, we have a radical. So I'm going to set the radicand to be greater than or equal to 0. If you solve that out, there's a few ways to solve these. You can use whatever works best for you. You do end up getting x is less than or equal to 1/2. So our answer is x such that x is less than or equal to 1/2. The last one, there's quite a bit going on. By the way, if you see like t's and s's in an equation as you're solving it out, you're welcome to change it to x. I know that t's usually look like plus signs and s's often look like 5s, so just be careful about that. So there's a lot of things in number 4. I'm going to start by setting the denominator to be not equal to 0. I know that s can't be equal to 8. And then the radicand I know needs to be 0 or greater. So if I solve that out, I get that x is greater than or equal to 4, or s, sorry. So my domain is the set of all s such that s is greater than or equal to 4. And s is not equal to 8. So I've listed the different function operations. I think the thing about these that gets the most confusing is just the notation. We sometimes write like the f plus g in one parentheses and sometimes not. In this class, you're mostly going to see it the first way. For the product, sometimes there's a dot in between the functions and sometimes not when you're multiplying. I just want you to be careful that you don't mix up, you don't need to write this down, but I want you to make sure that you don't mix up this with this. These are not the same thing, so just kind of keep that in mind. Go ahead, give these examples a try. Pause the video. Okay, so most of the mistakes that people tend to make with these actually have more to do with algebra than stuff related to the functions. So for the first one, when we're adding together the functions, we're just going to combine our like terms. We get x squared plus x plus 2. That's all we do for that one. I added an extra square and I'm going to erase that. Okay, so then for part B, the difference, we are going to subtract those. Just be careful about the algebra there. We get x squared plus 4 minus x minus 2. Biggest mistake in this one is this negative. Make sure that you distribute that negative to the 2 there. We end up getting x squared plus 4 minus x plus 2. And final answer is x squared minus x plus 6. For part C, this one you're just going to be using the FOIL method. And this is probably really similar to stuff that you've been doing for several years. So hopefully that one isn't too bad. I'm not going to do every step. D, this one, believe it or not, is the simplest, but it's the one where I get the most mistakes, and you might have even made a mistake on this one. So my answer for this one is x squared plus 4 over x minus 2. Okay, so I'm going to show you the mistakes that people make. This is what I get. So first thing that happens is people are like, okay, there's an x squared over an x. I can cancel that out. No, you can't do that. So that's the first thing you're not allowed to do. The second thing that people say is like, okay, I have a 4 over a negative 2. I can cancel that out, make this a 2, make that a 1. No, you also can't do that. the next thing they try to do is they try to factor the numerator, which if you could factor the numerator, that would be great, because then you would be able to cancel something out. But this one, it can't be factored. X squared minus 4 can be, but x squared plus 4, you can't do anything to. So actually, this is my answer. That's it. Can't do anything.